So let's look at another one. So for this one, to me, once again, it's very obvious the left side of this guy is way more complicated than the right side. And I'm looking at it and I don't even know where to start. I don't have any fractions to add together. There's no clever substitutions I see I can make. So what do you do when you're stuck? So I definitely know it's going to be easier to simplify this than the right side to expand. So here's what you do when you're absolutely stuck. Take the equation you're working with and rewrite it in terms of sine and cosines. And then hopefully an algebra step will jump out at you. So here's what I mean by that. So I'm going to leave the numerator alone. It's already sine theta. Cosecant theta is 1 over sine theta. And cotangent theta is cosine theta over sine theta. Now in the denominator, I have two fractions and they conveniently already have the same denominator, so I can combine these into one term. So I'm going to have sine theta over 1 minus cosine theta over sine theta. So I have sine divided by a fraction. So when you divide by a fraction, you multiply times the reciprocal. So now what I have is sine squared theta over 1 minus cosine theta. But what I want is a 1 plus cosine theta, and notice there are no signs in my right side that I'm trying to combine. So we already looked at the Pythagorean identity and saw that sine squared is equal to 1 minus cosine squared. So why don't we substitute that and turn it into a cosine and see what happens. So 1 minus cosine squared theta over 1 minus cosine theta. So a very tempting move here is to try to cancel something. You can't cancel anything. But what I have in the numerator is the difference of squares. So in the previous problem, I solved these two factors and they multiplied to this. Now what I've got is a 1 minus cosine squared, and I bet it factors, right? A plus b, a minus b. So I'm going to factor the numerator, 1 plus cosine theta times 1 minus cosine theta over 1 minus cosine theta. Now I can cancel these two guys, and voila, I found the right hand side, and I'm done.